In the last video, you would have seen me unbox and build this robot here, which is clicbot. In fact, the last model I actually built was this one here, Tiny Tail. And since I only have the starter kit, only 2 wheels are included. You know what I'll do? I'll press this button and I'll show you Tiny Tail in action. There you have it. Now, it occurred to me that what I could do is make a slight improvement which would avoid what was happening there, which is basically the part of the joint was rubbing against that disc. What I wanted to do was to maybe use one of the other parts and make it from a 2-wheeled robot into a 3-wheeled. Now, how I propose doing that is to use this part here, which is the holder. Normally used if I take this in to attach either, say, like a GoPro camera or this thing here, which is a mobile phone holder. It would allow me to get this robot here, clicbot, to hold onto my mobile phone, if you trust it, of course. Take this off for a second. Now, what I'm going to do is I'm going to take 2 parts. This is just a hex nut. Now, if you know anything about photography and tripods and so on, you'll know that the thread on here is 1/4 quarter across is the diameter. 20 is related to the density of the thread. So I'm going to put a hex nut there. Then on the end of that, I'm actually going to epoxy resin onto there, this thing here, which is known as a ball transfer bearing, which contains this thing here, a ball bearing. So maybe what I should do is I should attach these 2 together, then get it onto the holder and show you what I'm talking about. I'm going to design some 3-wheeled robots using clicbot, and then I'm going to show you how to control them. So what I'm going to do here is I'm going to take this hex nut and I'm just going to give it a little bit of light sanding. I'll not do that right now. Do exactly the same to this part here, the transfer bearing. Then I'm going to use a little bit of super glue just to get the bearing on top of the hex nut. Once that's done and the super glue's dried, I'll use a little bit of epoxy resin. Now, both of these glues have warnings on them, and it's really important, of course, if you're not old enough to use these, or if you're not experienced enough to use them, it does mention eye irritation, skin irritation, and so on. What could happen if you're not careful? So if, as I said, if you're not old enough or if you're not experienced enough, then please ask someone else who is both old enough and does have the experience to use them to help you out. Okay, here we go. I have now designed this 3-wheeled robot called 3-Wheeler Pete. And there's the part that I made. The hex nut connected to the transfer bearing. Screw that on there, and of course that, as I said, turns the clicbot into a 3-wheeler. Now, if I go to this part, go create, this is 3-Wheeler Pete here. You'll see one issue is, just looking at the model in the screen, comparing it to this one, this holder part doesn't seem to be detected by the robot. Not a great issue at all, but as I said, it now allows me to make it into any number of 3-wheeled robots. If I click here, I don't think I'm connected yet, but I'm going to show you me creating several different types of motion and then controlling clicbot using the remote control function. So if I go to create motion, attempt clicbot connection, okay. I've actually called this robot Dave, so connect to Dave, and on Dave's screen it says confirm connecting to the, or connection to the phone or iPad. It's iPad, so click OK, and if I click there, it resets to the position that I'd actually set 3-Wheeler Pete into, and then I'll go back to create your first motion. Now, first of all, I'll create a demo motion. So if I show you this robot, it looks a little bit, does it look a little bit like a dog? Some kind of animal anyway, with a tail at the back. So I'm going to create a motion where it wags its tail. So all I actually have to do is, I think I'll set this as the first position, click the button, the plus down the bottom right hand corner to set that position. Then it's going to move its tail to the right hand side, like so. Set that position again with the plus. Then it's going to go to its left hand side, the tail is, click plus, back to the right hand side, back to the left hand side, plus again, and finally back to roughly the starting position, which was in the center. That would do perfectly. Click plus, click down to the bottom left where it says demo motion, and just make sure, of course, everything's out of the way, and it should show you that motion, and that looks perfect. Try that again. Click confirm that nothing's in the way. Perfect. Now, what I'm going to do is now click the top right and give that motion a name, and I'm going to call it tail wag. Tail wag, get rid of the keyboard, click OK, and that's us. So we've created one motion. Right, the next thing I want to do is to set a rotation motion. I'm going to use this in order to get the robot to move forward. Now, again, as I said, it doesn't actually in the app doesn't detect this part here, as you can see on the screen. All I'm going to do is I'm going to select this wheel here, that's this one, and I want that, I guess, to move in this direction here, which is counterclockwise. So I think I'll get it to move fairly slowly, about 30%. There we go, and rotate around to here. And this wheel, which is this one here, I want now to move clockwise. And I get it to go at exactly the same speed, 30%. Like so. Move that back slightly. There we go, to the right hand side of the frame. Click rotation motion. Make sure that nothing's in the way, and hopefully, there we go. Right, to stop it, I just press the bottom left. There you go. This possibly isn't the most stable robot. You'll see when it started, there's a little bit of a wheelie. Could be a bit of a stunt robot. Now, I could, if I wanted to, save that motion as well. What will we call that? We'll just call it drive forward. Drive forward. There we go. Now, finally, click create again. I want to do a steering motion. This one's a little bit more complicated. Now, still not that difficult. First of all, I want to create forward drive pose. So if I click that button there, and basically when this is moving forward, I guess that's the pose it needs to be in. So all I have to do is click the tick at the top right hand corner, and that's us. Secondly, I want to click set forward drive speed. So I'll get it to go fairly slow, because as we said, this maybe isn't the most stable of robots. Again, like the last motion, maybe move that wheel at 30%, and that's counterclockwise. I want to move the other wheel clockwise at 30%, and tick. So that's me done for forward drive setting. If I click here, I can then set the left turning setting. So when I want this one to go left, let's see, I probably want to get that to just move the wheel slightly. Now, this part here is now no longer perfectly in contact with the ground, so maybe I'll rotate slightly as well. There you go, that's now perfectly in contact. And it's basically sitting perfectly on this transfer bearing. Now, so this is going to be a left turn. If it's a left turn, I guess this wheel is going to move faster than this one. But anyway, that's the left turn pose. That's me. And tick. I then want to select left turn speed. So as I said, maybe this right wheel can move, I guess it would move clockwise at 30%, but we'll move the other one at 10%. Why not? I think that's us. Now, finally, the right turn setting. So for the right turn, I want to basically get that to move in this direction, roughly the same angle as before. And I want this part here, the holder, to be perfectly aligned with the ground, so that this little ball bearing here is obviously rolling against the ground. And at this time, I want this left wheel, if it's taking a right turn, I want that to move faster. So I'll get this one to move, I guess that's anti-clockwise or counterclockwise, 30%. And this wheel on the right, forward at 10%. But that's me created right turn pose, and click tick. Set right turn speed. So as I said, I want this wheel on the left to move, it's this direction, counterclockwise, 30%. 25. Come on. 30. There we go. And the other one, we're going to get that to move at 10% forward. And I think that's me. Now I can, if I want, I can test that out by clicking the button in the bottom left. Let's see, I'll just get it nice and straightened up. So we'll move that forward. There it goes. Move it back. Move it forward and right. Straight back. Move it forward and left. All looks perfect. Now, we can, if we want, we can actually put these all together and basically create a remote control for a robot so that it can actually just move around, and of course it can wag its tail as well. Final thing I'll do is I'll save this as remote control. Remote control. And okay. Final thing I want to do is to click the top right hand corner and select one of these motions. So what I'll do is maybe actually this one would do. No, in fact, I think I'll take that one. Yeah. So I'll take this one, click the tick, and down the bottom left, if I click there, you can see all of these motions that I've saved. So in one of these buttons in the top right hand corner, I'm going to place tail wag. I just drag that up to there. Now, of course, there is space for 6 different motions. And remote control, I will just drag to this controller in the left hand side, and I think that'll do me. Click tick. Let's test out that tail wag first. So press the button. Perfect. And what about moving it around? Well, looks good to me. Right, we'll get it to move just one last time. Now, as I said, this isn't the most stable robot in the world, so that's why I only set the speed at 30%, because if it goes off any quicker, it tended to go backwards. Of course, it would get stopped by this part here, the skeleton. So next video, I'm going to show you how to actually program the robot using programming language, but this is basically all I want to do in this one, just to show you how to make an extra part to make this robot from, or take the robot from being a 2-wheeled robot to a 3-wheeled robot, and then control its motion.